Next is information system. An information system is any organized system for the collection, organization, storage, and communication of information. Specifically, it is the study of complementary networks that people and organizations use to collect, filter, process, create, and distribute the data. An information system is a group of components that interact to produce information. A computer information system is a system composed of people and computers that process or interprets the information. The term is also sometimes used in more restricted senses to refer to only the software used to run a computerized database or to refer to only a computer system. Information system is an academic study of systems with a specific reference to information and complementary networks of hardware and software that people and organizations use to collect, filter, process, create, and also distribute data. An emphasis is placed on an information system having a definitive boundary. Users, processors, stores, input, output, and the aforementioned communication networks. Any specific information system aims to support operations, management, and decision making. An information system is the information and communication technology that an organization uses, and also the way in which people interact with this technology in support of business process. There are six components that must come together in order to produce an information system. They are hardware, software, data, procedures, people, feedback. The term hardware refers to machinery. This category includes the computer itself, which is often referred to as the central processing unit, and all of its support equipments. Among the support equipments are input and output devices, storage devices, and communications devices. The term software refers to computer programs and the manuals that support them. Computer programs are machine readable instructions that direct the circuit within the hardware parts of the system to function in ways that produce useful information from data. Programs are generally stored on some input-output medium, often a disk or a tape. The data are the facts that are used by programs to produce useful information. Like programs, data are generally stored in machine-readable form on disk or tape until the computer needs them. Procedures are the policies that govern the operation of a computer system. Procedures are to people what software is to the hardware. Is a common analogy that is used to illustrate the role of procedures in a system. Every system needs people if it is to be useful. Often the most overlooked element of the system are the people, probably the component that most influence the success or failure of the information systems. This includes not only the users, but those who operate and service the computers, those who maintain the data, and those who support the network of computers. Feedback is another component of the information system that defines that an information system may be provided with a feedback. What are the types of information system? Some types of information system are data warehouse, enterprise resource planning, enterprise systems, expert systems, search engines, geographic information systems, global information systems, and office automation. A computer-based information system is essentially an information system using computer technology to carry out some or all of its planned tasks. The basic components of computer-based information systems are hardware, software, database, networks, and procedures. So hardware, these are the devices like the monitor, processor, printer, and keyboard, all of which work together to accept, process, show data and information. Software are the programs that allow the hardware to process the data. Database are the gathering of associated files or tables containing the related data. Then networks are the connecting system that allows diverse computers to distribute resources. Procedures are the commands for combining the components about to process information and produce the preferred output. The first four components make up what is known as the information technology platform. Information technology workers could then use these components to create information systems that watch over safety measures. Risk and the management of data. These actions are known as information technology services. Next, we will see organizational intelligence. Organizational intelligence is the capability of an organization to comprehend and conclude knowledge relevant to its business purpose. In other words, it is the intellectual capacity of the entire organization. With the relevant organizational intelligence comes great potential value for companies, and therefore organizations find study where their strengths and weakness lie in responding to change and complexity. Organizational intelligence embraces both knowledge management and organizational learning, as it is the application of knowledge management concepts to a business environment, additionally including learning mechanisms, comprehension models, and business value network models, such as the balanced scorecard concept. So what's the difference between operational intelligence and organizational intelligence? Organizational intelligence and operational intelligence are usually seen as subsets of business analytics, since both are types of know what, know how that have the goal of improving business performance across the enterprise. Operational intelligence is often linked or compared with real-time business intelligence, since both deliver visibility and insight into business operations. Operational intelligence differs from business intelligence in being primarily activity-centric, whereas business intelligence is primarily data-centric and relies on a database, as well as after the fact and report-based approaches to identify patterns in data. Next, we will discuss about process mining. So process mining in business intelligence is a technique under process management that allows for the analysis of business process based on event logs. During process mining, specialized data mining algorithms in order to identify trends, patterns, and details contained in event logs recorded by an information system. Process mining aims to improve process efficiency and understanding of process. Process mining is also known as automated business process discovery. So automated business process discovery. So process mining techniques are often used when there is no formal description of the process that can be obtained by other approaches, or when the quality of existing documentation is questionable. For example, application of process mining methodology to the audit trials of a workflow management system. The transaction logs of an enterprise resource planning system or the electronic patient records in a hospital can result in models describing process, organizations, and products. Event log analysis can also be used to compare event logs with prior models to understand whether the observations conform to a prescriptive or descriptive model. So process mining techniques are often used when no formal description of the process can be obtained by other approaches. Event log analysis can also be used to compare event logs with prior models to understand whether the observations conform to a prescriptive or a descriptive model. So process mining follows the options established in business process engineering, then goes beyond those options by providing feedback for business process modeling. Process analysis filters, orders, and compress log files for further insight into the connects of process operations. Process design may be supported by feedback from process monitoring. So process enactment uses results from process mining based on logging for triggering further process operations. So there are three types of process mining techniques. The first one is discovery. The second one is conformance checking. The third one is extension. So discovery phase. Previous models do not exist. Based on an event log, a new model is constructed or discovered based on low-level events. For example, using the alpha algorithm, many established techniques exist for automatically constructing process models based on an event log. Recently, process mining research has started targeting the other perspectives. One example is the technique described, which can be used to construct a social network. Then we have conformance checking. It is used when there is an a priori model. The existing model is compared with the process event. Discrepancies between the log and the model are analyzed. For example, there may be a process model indicating that purchase orders of more than 1 million euro requires 2 checks. Another example is the checking of the so-called 4 eyes principle. Conformance checking may be used to detect deviations to enrich the model. An example is the extension of a process model with performance data. That is, some a priori process model is used to project the potential bottlenecks. Another example is the decision miner, which takes an a priori process model and analyzes every choice in the process model. For each choice, the event log is consulted to see which information is typically available the moment the choice is made. Then classical data mining techniques are used to see which data elements influence the choice. As a result, a decision tree is generated for each choice in the process. Then finally, extension. It is used when there is a priori model. The model is extended with a new aspect or perspective so that the goal is not to check conformance, but rather to improve the existing model. An example is the extension of a process model with performance data. That is, some prior process model dynamically annotated with performance data.
Then we have software for process mining. So a software framework for the evaluation of process mining algorithms has been developed, and it's available as an open source toolkit. Next, we have competitive intelligence. So this is the action of defining, gathering, analyzing, and distributing intelligence about products, customers, competitors, and any aspect of the environment needed to support executives and managers making strategic decisions for an organization. Competitive intelligence essentially means understanding and learning what's happening in the world outside the business, so one can be as competitive as possible. It means learning as much as possible, as soon as possible, about one industry in general, one's competitors, or even one's country, particular zoning rules. It empowers anticipating and facing challenges head on. So competitive intelligence is an ethical and legal business practice as opposed to industrial espionage, which is illegal. The focus is on the external business environment. There is a process involved in gathering information, converting it into intelligence, and then using it in decision making. Some competitive intelligence professionals mistakenly emphasize that if the intelligence gathered is not usable or actionable, it is not intelligence. The term competitive intelligence is often viewed as synonymous with competitor analysis. But competitive intelligence is more than analyzing competitors. It is about making the organization more competitive relative to its entire environment and stakeholders, customers, competitors, distributors, technologies, and macroeconomic data.
So next we'll see modern data integration. So business faces huge competition these days due to the advancement in technology. Organizations should be able to utilize information and create new knowledge to lead their business. So innovations in technology and the interconnectivity, enormous amount of data every day. So, innovations in technology and the interconnectivity, enormous amount of data every day. So, innovations in technology and the interconnectivity, enormous amount of data every day. So, innovations in technology and the interconnectivity, enormous amount of data every day.
So data integration helps to move the data from the source to the target. So we will discuss the concept of modern data integration. Many organizations are using data integration talent to create value for their business. Data integration becomes more important when two companies are merging or when consolidating applications within a company to provide a view of the company's data assets. The data integration applications do not work simply. They need codes to do the process. A lot of problems will arise related to its maintenance, documentation, and transference. So what are the data integration areas? So it has data warehousing, data migration, enterprise application, then master data management. So what is the data integration process? So there are three phases. One is design, so this process should involve all the departments in a company. In this process, you should ask yourself a few questions. So what are the objectives of data integration? What are the sources from which data can be derived? Is it available? Is the available data enough to meet the requirements? Does the data integration go with the business rules? What is the support model? What are the SLA requirements? What are the ways to extract the data from the source? What is the quality of the data? Is there a need for other non-functional requirements, such as data processing need, security policy backup, policy, and others. Who will be the owner of the system, and what will be the total amount of expense? So the answers to all the questions should be documented and signed by all the members who are involved in the data integration project. So the second phase is implementation. So based on the analysis of the requirements and the SRS document, a detailed study is performed to select the appropriate tools to implement the data integration system. There are a lot of tools available in the market, and selecting the best tool for your business is the biggest challenge. Companies that are new to data integration need to implement a new tool, and companies who have already used or used such projects can just extend their existing system. Selecting the best tool that suits your business need will be more effective, and it will help for future growth and expansion of the business. Then the next phase is testing. So testing is an important phase of data. Proper testing is needed to make sure that the unified data are complete and correct. The IT department and the entire business need to take part in the testing process. The different testing methods that can be used are performance stress test, technical acceptance test, and user acceptance test. The next is techniques. So there are several data integration techniques performed by companies. So manual integration or common user interface, application-based integration, middleware data integration, uniform data access or virtual integration, common data storage or physical data integration. So manual integration or common user interface provides the users access to all the source systems or web page interface. Application-based integration is used only when there is a limited number of applications. Middleware data integration helps to transfer the logic from one application to a new middleware layer. Then uniform data access or virtual integration defines a set of views to provide access to the users to the unified view of the data. Then common data storage or physical data integration has a copy of the data from the source and stores and manages it independently in the original system. Then what are the products of data integration? So primarily there are three products of data integration. One is ETL, extract, transform, and load. Enterprise application integration products. Enterprise data replication. So ETL products help to move the huge amount of data, which also enables robust transformations. Then enterprise application integration products help to move smaller quantities of data with different frequency patterns. Then enterprise data replication. These products give information about the data sets and when they have to be changed or modified. Next is principles of data integration. We live in an era of data. Modern data is more complex and it has different types, sources, volumes, and locations of data. Modern data has a lot of advantages. There are a lot of principles for modern data integration to meet today's data environment. So there are basically 5 principles. So the first one is take the processing to where the data lives. So there is a lot of data and you need to blend the data every time before you transfer it. Point an agent in the host platform so that all the process is done locally before the data is transferred. By moving the processing system to where the data lives will reduce the movement of the data through the network, which in turn will save the time. Then leverage all the platforms based on the design. If you are making investments in modern data platforms, every platform will have a default set of functions and workloads. It uses those default functions within the application. In this way, the performance of the data blending can be improved. and the data movement can be reduced. Then move data point. So modern data platforms should be centrally engaged with all the business rules and data logic. It is possible only when the local processing system is kept separate from the central design studio. Managing the business rules and data logic can help to maximize their usability and provides transparency.
Then the next one is make changes using existing rules. If the management is handled centrally, all the business rules and data logic templates can be kept under a single roof. If there is any change to be made to the data or platforms, then such changes can be made quickly and efficiently. So what are the benefits? So it will eliminate all the challenges raised by the legacy technology. So the main benefits are design once and use many times. Then gain in-depth knowledge about the data. Manage the complex data environments. Then optimize the actions. Ability to change, extend, and migrate existing business data. Respond quickly to business needs.
So what are the new requirements? So there are some new requirements for the modern data integration. So the business world becomes more competitive. They depend more on data. More accurate data lets the business people to make smart decisions. Data volumes are growing bigger every day, and the business needs their data to be processed faster to gain better results. The data sources and IT environments change frequently, and it becomes more complicated to get detailed knowledge about the data. As a result, new requirements have evolved for modern data integration. So let's see them. So the first one is application integration is done through REST and SOAP web services. So today's software applications are implemented as cloud-based services that will expose the SOAP or REST APIs for the data and metadata management based on business goals. In today's scenario, SaaS applications restrict access to the database behind their services. Modern data integration offers an easy and quick way to use REST and SOAP web services. They should provide an easy way to use these APIs in business. The second one, high volume data integration is available to a Hadoop-based data lake. IT departments in an organizations are moving apart from data warehouses and moving towards data lakes that are the central location of data based on the Hadoop cluster. Spark is the most recent technology used to transform data of large amounts in this environment. Cloud data warehousing technologies act as a substitute for expensive data warehouse applications. So data integration tools have to be easy to access and understand, and it should process large-scale distributed frameworks such as Spark.